So this lab is the endothermic exothermic lab. So we're going to be doing two reactions. There's two parts to this. And you can see here's the two reactions we'll be doing. So take a second to read through the procedure, at least part one, and then I'll do part one and then read through part two. I'll do part two after part one, obviously. You'll see it in the video. So take a second, read part one. The first thing we're going to do is we're going to hook up the temperature probe, and we got to do some settings in Logger Pro. So we're actually using the LabQuest for this, or our computers. First thing you got to do is hit the data collection, set it to a time limit that's longer than we need. So it says 300 in the lab, but I just put it to 100. And then half of a sample per second, so a sample every 2 seconds. So you want it to take a sample every other second. There we go, just having some computer problems here. There we go. So then the LabQuest needs to get plugged into the computer. I actually use Go links, they're like the adapter. The actual sensors plug into the Go link. Then the first step, we need, I believe, 20 milliliters of citric acid. So there you go, 20 milliliters of citric acid. The magic of editing. And we're using a calorimeter, so we're going to be measuring how much the temperature changes in the reaction, but we have to use a beaker because the acid actually eats away the metal can of the calorimeter. Then we're going to be mixing baking soda, 5 grams of it. So there's 5 grams of baking soda. And now before we actually mix them together, so everything's ready to go, we're going to put the temperature probe in and get an initial temperature. So on the back of your paper, be ready to write down the initial temperature for part one. So we're going to hit play, get a baseline reading. So you can see your initial temperature is 22.5 degrees Celsius. So pause the video, go write 22.5. Yeah, 22.5, 22.4 doesn't make a difference. So now that we got the baseline reading, this isn't perfectly in order here, but you're going to add the baking soda. So the baking soda was added, and you're going to see what does that do to the temperature. So you can see the temperature starts to drop. And then you're going to wait for the temperature to level off on the bottom to get the final reading. So when it levels off, or the lowest reading, write that as your TF, your final temperature, temperature final. So you can actually see it drop down a little bit lower. That's because I stirred it and then it reacted a little bit more and dropped again. But it's leveling off here real soon. So you see 6.3 is getting real close. I think that might even end up being our lowest number here. So yeah, it's starting to go back up. So 6.3 is going to be the final temperature. So then find the difference between the final and the initial temperature. And I'll just show you what the reaction looks like. So while the temperature was going down, this is what was happening. So you can see it gives off a lot of gas. So this is what was happening as the temperature dropped on the previous chunk of video. And that's where I stirred it. So again, write down your initial temperature before it reacted, your final temperature after it reacted, and then you're going to have to calculate the change in temperature by taking the final minus the initial, and show your work. And then also says draw a rough sketch of the graph. So just draw a rough sketch of what it looked like. It was level, it dropped, then it leveled off again. You'll get to do the second one on your own. I'll give you the first one. Now we're going to do part 2. So take a second, read those directions. And then be ready to write down your initial and final temperature for part 2. And then you'll draw the graph. So we're mixing hydrochloric acid, 2 molar hydrochloric acid. I believe it's 30 milliliters. There you go, there's your 30 milliliters. We'll add that to the beaker, again, so it doesn't react with the metal cup. We'll add the cap, and all these things these are calorimeters. They're just an insulated container so that the heat change doesn't get lost to the surroundings. So we got this is the last graph. We have to delete this trial, and then we have to get the baseline for part 2. So you can see it looks like the initial temperature is 23 degrees Celsius. And then we're going to add the chunk of magnesium. And I don't show you this one, but this one gives off bubbles. It looks very similar to the last one. Reacts, gives off a gas. And then let's take a minute to watch the temperature change of this reaction. So you can see this one goes up. While you're watching this one go up, I'll explain the difference between endo and exothermic. Endothermic reactions are reactions that take in energy. Exothermic reactions are reactions that give off energy. Now you got to realize your thermometer in there is a part of the surroundings. So a reaction that gives off energy is going to give it to the thermometer and make the thermometer hotter. So in this particular case, you can see the temperature, the energy is flowing from the reaction into the thermometer, making the thermometer hotter. So this would be an exothermic reaction. The other scenario, the first part, the reaction takes in energy, so it's actually stealing energy from the thermometer, making the thermometer colder. So it's taking energy in. The reaction itself is absorbing energy, and makes the thermometer colder. So the first one would be your endothermic reaction. There you go. It looks like the temperature's leveling off at 33.3. You can see it's not really changing anymore. Okay, so get your data for that, answer the questions, make sure you show all your work in the calculations, and get the questions done. explain how you labeled the reaction exo and endothermic. So I just talked about that in the last, I guess, slide when we were going over the data or watching the temperature change. Ask questions if you need help on any of these, but do your best to get them done.